Okay, today we're going to be talking about graphing and writing quadratic functions in factored form. And factored form is going to make it easy for us to find the x-intercepts of our graph. So it's going to look like this. We're going to have the a value in the front and then our two factors right next to it. And these factors are going to tell us where our graph crosses the x-axis. To do this, I'm going to set each of these factors equal to 0 and solve for x. As a reminder, a graph is going to be stretched if we have an a value greater than 1. So this could be a negative or it could be a positive a. Remember, the negative, all that does is it reflects the graph and makes it look like this, upside down. But if the number itself is greater than 1, it's still going to be a vertical stretch. On the other hand, if a is a fraction less than 1 or a decimal less than 1, it's going to be a vertical compression. So this could be like 1/3 x squared or 0.5 x squared. Again, any of those could be negative. That doesn't matter. The negative, all it does is reflect the graph. So when working with our factored form, we are going to find the vertex by finding the halfway point between our x-intercepts. Okay, so first we are going to graph those x-intercepts, and then we're going to find where the middle is between those x-intercepts. Then once we have an x value, we are going to use that x value and replace it back into the original. So we're going to substitute to find the y value of the vertex. And this is back in the original function that we started with. The x-intercepts, like I said in this part, are the easy part for factored form. You're going to set each factor equal to 0 and solve for x. Okay. And lastly, our y-intercept for all forms, this works. You are going to set x equal to 0 and simplify. Okay, so the first example we are going to do here, we have looking at the form in front of my factor, that's where my a is, and if there's nothing there, it's invisible, it's a 1. So because a is 1, it's not going to be stretch or compress. And because a is positive, it is not reflected. Okay, so after I identify my a, and those are the questions I can answer with my a value, I'm going to go ahead and move on to the x-intercepts because that's the easy part given factored form. So I'm going to take each of my factors. I'm going to start with x minus 2. I'm going to work down here. So x minus 2, and I'm going to set it equal to 0. Then I'm going to solve for x here, and I get x equals positive 2. So that is my first x-intercept at 2, 0. Then I'm going to take my other factor, x plus 4. I'm going to set it equal to 0. Subtract 4 from both sides. I get x equals negative 4. So I have two x-intercepts, one at positive 2, one at negative 4. Okay, so again, this is just because we are in factored form, I can go ahead and just do that. Next thing I want to do is find the middle point. So that is going to be my next step to finding the vertex and the axis of symmetry. I want to know what the middle point is between negative 4 and 2. So two ways you can do this. I'm just going to show you by counting. So we have 1, 2, 3, 4, 5, 6 points between our two x-intercepts. And so then I'm going to say, okay, so 6 divided by 2, the halfway point would be 3 away. So 3 away from each of my intercepts would put me right here at negative 1. And a way that you can check your answer is this axis of symmetry should be equally away to the right 3 and to the left 3. So my axis of symmetry happens to be at negative 1, which also happens to be my vertex x value. Now I got to figure out where my y value is going to be. So to do that, you are going to take the x value that you found, and you're going to substitute it back into your original function. So I'm going to replace any x with a -1, and then I'm going to simplify. So -1 minus 2 is -3, times -1 plus 4 is +3, which gives me a -9. So this tells me that -9 is my y value. So my vertex is actually at -1, -9. So in this case, our vertex just requires that we do some different work. You just find the x value first and then go ahead and plug it back into the original function to find your y. Next, to find the y-intercept, I know that the y-intercept is where the x value is 0. So again, I'm going to take my original function right there. And for every x, I'm just going to substitute in a 0, which leaves me with -2 times 4, and that is -8. So that is my y-intercept. I can use symmetry to plot one more additional point. And now I am able to connect my dots. So this is what my graph looks like. Because my graph is opening up, I have a true minimum value. And that minimum value is based on the y value of my vertex. So we are at x equals -9. So remember, these should always match your either minimum or maximum value along with your vertex. As well as your axis of symmetry. Let me do that in a different color. So your axis of symmetry value and your vertex x value should also always match. Next thing that I need to find is the increasing and decreasing interval. So increasing, you want to think about which part of your graph has a positive slope. And looking at this half of my graph has a positive slope. For increasing, decreasing, positive, and negative, all of those values should be x values. So think about what is that x value where that starts increasing. That is at -1, and it continues increasing until positive infinity, forever to the right. The decreasing interval comes from the left, so we call that -infinity, and it goes decreasing until we get to that same point, -1. So again, -1 should match, maybe in separate orders, but it should match my vertex x value, my axis of symmetry, and then the increasing and decreasing interval, so should have that somewhere on it. Okay, then moving on to my positive interval and negative interval. So positive interval is any part that is above the x-axis. So above the x-axis, I have this part and this part. And again, you want to think positive above x-axis, and these are all x values. So on the left-hand side, it goes from -infinity, and then it stops being positive right there at -4. And then we're going to use a u, or you can say the word and. It starts being positive again from +2 all the way to the right, positive infinity. Okay, and this time, those numbers are going to match my x-intercepts, because if you think about it, your x-intercepts is where things stop being positive and start being negative and vice versa. So you shouldn't be using any new numbers. Like, these should all kind of connect and come together. The last part of this is going to be my negative interval, and negative interval means below the x-axis. So this is one continuous part of the graph. It's all of this, and it's going from -4 to +2. And again, these numbers should all match. I'm not coming up with any new numbers, just using the same ones based on my x-intercepts. Your domain for quadratics will always be -infinity to positive infinity. You can say all real numbers, or you can draw that R. Then we have the range. Because this graph opens up, it has a minimum, so I'm going to start off down at -9. Remember, range is the only place where you should be using brackets, and it's going to go up forever to infinity. And this number should also match your minimum or maximum, depending on which way it's opening, and your y value for the vertex. And lastly, we want to describe the translation. So how did this translate? The graph translated left 1 unit. It also went down 9 units. And there's no stretch or compress or no reflection, so no need to mention anything there. Okay, going on to example 2. This time my a value is a -1, which means this one is reflected, but it is not compressed or stretched because it's still 1, and the negative, all that does is reflects my graph. So this one should be going like this. That means it's going to have a maximum. Okay. So again, start off by taking these intercepts and setting them equal to 0. I have x minus 4 equals 0, so x comes out to be 4. That's my first x-intercept. And then I'm going to take x plus 2 and set it equal to 0, which means I have another x-intercept at -2. So I'm going to go ahead and graph those. I have -2 and +4. We want to find the halfway point between -2 and +4. In this case, that middle point is going to be +1, which is going to be your axis of symmetry. And it's also going to be your vertex x value. To find the y value, we are going to use that x value that you just found and substitute it into the original. So I have a -1 minus 4, 1 plus 2. The negative follows the problem the entire time. So when I multiply this through, I get a +9. Therefore, my vertex y value is up here, which makes sense because it kind of shows that my graph will be opening down because, again, it is reflected based on that -1 value. Next is the y-intercept, and the y-intercept is when x equals 0. So again, you're going to take your original equation and you are going to replace any x's that you see with a 0. And in this case, that's going to give me a +8. So that's my y-intercept. I can use symmetry to plot one more point and then sketch my graph. Okay. Next, we are going to do our increasing and decreasing intervals. So increasing is where we have a positive slope. Our increasing interval is going to be x values always. So it's coming up from the left and it stops increasing at that x value of the vertex, which is 1. And if it's not increasing, that's where it starts decreasing. So again, it picks up at 1 and then it goes down a negative slope until +infinity. Before I forget, I gotta go back to my maximum. I need to express my y value that is the maximum. And in this case, that y value is 9, which remember, this number should match your y value for the vertex. Next, I am going to do positive interval. So this case, positive interval is just one continuous interval. So again, look at your x value where it starts. We start positive at -2, and it stops being positive at +4. And wherever it is not positive, it is negative. So it goes from the left, -infinity, and it stops being negative at -2. And there's a second part that's negative starting at 4 here and then forever to the right. So 4 to +infinity. Our domain for a quadratic function is always going to be the same. And that's -infinity to +infinity. You can say all real numbers. The range in this case, this graph goes forever down. So you start at -infinity, but it does have a maximum. So it's going to stop at 9, and that's where you're going to use the bracket. And lastly is describing this translation. So use your vertex and your a value to talk about what happens to this graph in comparison to the parent function of just x squared. So this graph moved, it translated right 1. It also translated up 9. And it is reflected across the x-axis. So this graph is doing all those things in comparison to the parent function of x squared. Okay, for example 3, now we have an a value that is a positive 2. So because it's positive, it's not reflected, but this time it is being stretched. So anytime that we have any number greater than 1, it's going to be stretched, and in this case, it's by a factor of 2. So this graph is opening up. It is going to have a minimum, and we're going to find out what that minimum value is after we find the vertex. So start off by using your factors, setting them equal to 0, and figuring out your two x-intercepts. So I have an x-intercept at 1, 0, and I have an x-intercept at -3, 0. So now that we have our x-intercepts, we have to find the middle point here. And the middle point, we have to first count. We have 1, 2, 3, 4. So half of 4 is 2, which means that my middle point is going to be at -1. So that's the axis of symmetry at -1. That's going to be the x value of my vertex. And then I'm going to use that x value of my vertex and substitute it into the original function. So I have 2 parentheses, -1 plus 3, -1 minus 1. And then go ahead and simplify that. And that's going to give me -8. Okay, so that means that we are down here for our y value of the vertex, which is also going to be my minimum value of -8. For my y-intercept, I know that's where x equals 0. So I'm going to take my original function and replace any x I see with a 0. So that simplifies to 2 times 3 times -1, which is -6. So that's going to be right there, and I'm going to use symmetry to plot one more point and then be able to sketch my graph. Oh, I missed that one. Let me try again. Okay. So now that I have a general idea of my graph, I'm able to answer the other parts of this. So increasing interval is where my slope is positive, so I'm increasing here. And those are going to be your x values. So x value matches my vertex, so I'm increasing from -1 to positive infinity. And if I'm not increasing, I am decreasing. So in this case, I'm decreasing from the left all the way over to -1. So decreasing from -infinity to -1. My positive interval is where I'm above the x-axis, so that's this part and this part, again, using x values. So coming from the left, stopping at -3, and then picking up again at our other x-intercept of 1, going forever to the right. And wherever it is not positive, it is negative. So in this case, it's this continuous part of the graph. And for us, that's going to be from -3 to +1. Again, using those x-intercepts. That's where it stops being positive, starts being negative, and vice versa. Okay, the last part of this is domain. So -infinity to positive infinity is always the answer for quadratics. The range, this one does have a minimum at -8, and then it does go up forever to positive infinity. And lastly, the translation I'm going to describe as, this graph is stretched by a factor of 2. And I got this number factor of 2 based on the a value. This graph also translated left 1 and up, down 8. Okay, so now we are being asked to write the quadratic function in standard form for the parabola passing through the point -2, 3, and having x-intercepts at -3, 0, and -1, 0. So first of all, when they're giving us a point, these are going to be labeled as x and y. And as we saw at the beginning of the notes, the x-intercepts were represented as p and q. So the general form of a quadratic function in factored form was a x minus p, x minus q, or plus, it doesn't matter, you would set them equal to 0 and go from there. So in this case, my y value is a 3, so I'm going to substitute f of x with 3. My a value is something that I don't know, so that's actually what I'm trying to figure out. My x value in this case is -2. My p value, so you got to be careful here because remember that you end up setting the factors equal to 0. So in order for me to get a -3 as my x-intercept, I would actually need to have a factor of x plus 3, right? Because when I set it equal to 0, that's how I get the -3. So inside, this is going to be a plus 3. So kind of think of it as switching the sign there. Moving along, I'm going to use the same x value for my second factor. So I have a -2 here. And again, being careful that this needs to end up being a -1 when I set it equal to 0. So I'm going to go plus 1 on the inside. So your goal here is to solve for a. So you want to go ahead and simplify the parentheses. So I have 3 on the left, a times -2 plus 3 is 1. -2 plus 1 is -1. Multiply these two together, I get a -1. And you are first solving for a, so I'm going to divide by -1 to both sides and end up with a equals -3. Now that you have your a value, your final answer needs to have the a value and it needs to have the x's in it. So my final answer here is f of x equals -3, x plus 3, x plus 1. Making sure you change those to a plus 3 and a plus 1 because again, if I were to set these factors equal to 0, that's how I end up with the -3 and the -1. Okay, the last question we're going to do together is number 6, and then you are going to try converting from all forms for number 7, parts A, B, and C. So number 6 is asking me to write the equation of the quadratic in all 3 forms. And to do this, I need to use my graph and pick a point and the x-intercepts and go from there. So here's my first x-intercept. I have an x-intercept at 3, 0. I have another x-intercept at 5, 0. And then another point that is very clear is my vertex, and this is going to be at 4, 2. So I'm going to start off by using factored form. And factored form gives me the factors already as part of the equation. So in this case, it would be x minus 3 and x minus 5. Again, remembering that I need to change the sign because when I set them equal to 0, that's how I get the positive 5 and the positive 3. I need to figure out what a is. And then for the f of x and the x, since I need to figure out what a is, I'm going to just use my vertex, which is clearly stated in my graph. So I have 2 equals a. The x value here is going to be 4. And so I'm going to just replace my x values with that and then simplify. So this is 4 minus 3, which is 1. 4 minus 5, which is -1. 1 times -1 is just going to be -1. So I'm going to divide by -1 to both sides. And so I end up with a equals -2. So my factored form here is going to be f of x equals -2. And then x minus 3 and x minus 5. So you know that your equation is complete when you have an a value and your equation actually has x's as part of it. You don't want to have numbers only. That's not what the equation should look like. So thinking about my other forms, I also have vertex form, which is another easy one once you know the vertex. So vertex form is a x minus h squared plus k. At vertex form, we have a, which we found over here when we did the factored form. And so using a is -2. I'm going to substitute a with -2. Then x is going to stay as part of my equation. H is going to be the x value of my vertex. So in this case, that's going to be a 4. And remember, it's the opposite sign inside the parentheses. And then the plus k, that's going to be the y value of my vertex, which in this case, it's a +2. And that is your answer. So now that we found A, it's easier to find the vertex form. And the last form we are going to write down is standard form. So standard form looks like this: ax squared plus bx plus c. And to get to standard form, we are going to have to take factored form and multiply it out. So I'm going to multiply out x minus 3 times x minus 5 first. So I'm going to multiply these through, double distribute. I have x squared minus 5x, and then -3 times x is -3x plus 15. Combine your like terms here. You get x squared minus 8x plus 15. Then I'm going to bring down that -2 and then multiply that through everything inside the parentheses, which simplifies to -2x squared plus 16x minus 30. Very standard form. Okay, so this is how you go ahead and go from one form to another. So on your own, you're going to go ahead and try number 7, all of these. So it's asking you to write in the 2 other forms. So if it's in standard, you're going to want to put it in factored and vertex. If it's in vertex, you're going to do factored and standard, and so on.